Everyone, we are continuing with polar graphs, just a little more practice. So first thing is we are given 2 plus sine of 2 theta from 0 to pi, and we're asked to find the area. Well, I would definitely want to graph this because this looks a little funky. So if we look at the graph of this, between 0 and pi, it looks like a weird kind of curve here. Right? If you graph from 0 to 2 pi, it looks kind of like a peanut. Okay? It finishes the bottom, it looks kind of symmetrical. So here it looks kind of weird, but anyway, so that's what our graph looks like. So we'll go ahead and try to sketch that. So I start at 2, up here I'm at 2, down here I'm at 2, kind of does that sort of thing. It kind of goes up and goes down. All right. So they ask us to find the area bounded by this. So this is probably going to be a calculator problem. But, so we're going to let our area be, again, 1/2. I'm going from 0 to pi because that's what they told us to do. 0 to pi of my r squared d theta. And so if in your calculators you input this into your R1, then you could definitely set up your integral much easier. So once you go to your integral, we're going from 0 to pi. Just remember to select your R1, remember to square it with respect to theta, and just remember to multiply this by 1/2. Right, and you should get 7.068. All right, next they ask us to find the angle that corresponds with the point with an x coordinate of -1. So I have to define what x is. Well, I know that x is r cosine of theta. I know that r is 2 plus sine of 2 theta. Yeah, this is what my r is equal to. So 2 plus sine of 2 theta times cosine of theta. Right, and all this has to be equal to -1 because that's what I want x to be equal to. Well, again, this is going to be a calculator problem. You can use your solver for this. You can use the graph, find the intersection, find the zero, whatever, however many methods you have for solving this. But either way, you end up getting that theta is 2.630. Right, so this is a good problem for your solver. Alternatively, I personally like using the graph, but kind of up to you. Okay. If you have a TI-89, then here's some instructions. Okay, so they ask us to find the value of dr d theta at 5 pi over 7. Okay, so I know what r is. They defined it as 2 plus sine of 2 theta. So dr d theta is just the straight up derivative of this. So it's going to be 2 cosine of 2 theta. Don't forget to do your chain rule. Right, and they ask us to evaluate at 5 pi over 7, which is not a normal unit circle number. So we plug that to our calculator, we get negative 0.445. All right, so they're asking us, what does this tell us about r? Keep in mind that this is our derivative and it came out negative. So that means that because dr d theta was negative, that means r is decreasing. Okay, so similarly to just regular rectangular coordinates, if your first derivative is negative, that means that your original function is decreasing. So because dr d theta was negative, that means that r is decreasing, meaning that like my radius is decreasing, so the curve is getting closer to the pole. Okay, it's getting closer and closer to the origin, say. So we could write that. Okay, the curve is getting closer to the pole, meaning it's just kind of coming in and in and in. All right. And last one. They give us the same r equation, and they give us that d theta dt is 3. They ask us to find dx dt at pi over 6, and then interpret what this is telling us. Okay, well, in order to find dx dt, I need to first establish what x is. So x is going to be r cosine of theta. So r is 2 plus sine of 2 theta times cosine of theta. Okay, and so I need to find dx dt. So dx dt is straight up derivative. So I do need to do product rule here. So my derivative of sine of 2 theta is going to be 2 cosine of 2 theta times cosine of theta times d theta dt. Right, that's very important to remember because theta is not my variable here, t is my variable. So I need to multiply by d theta dt, just like I did with related rates or implicit differentiation. Right, plus this time 2 plus sine of 2 theta is going to chill. And the derivative of cosine is negative sine of theta, d theta dt. Okay, well, they asked us to evaluate when theta is pi over 6. Okay, so I'm going to plug theta in. Every time I see theta, I'm going to plug in pi over 6. Every time I see d theta dt, I'm going to plug in 3 because that's what they gave me. I guess that's constant. And that you can do that in your calculators. You end up getting negative 1.700. You know what? I'll put another decimal there because of all the zeros. So I get negative 1.7009. Okay, so they ask us to interpret what this means. And so because my derivative is negative with respect to x, okay, so my x derivative is negative, that means that my original x is decreasing. Because dx dt is negative. Okay, that is it. See you later.